Morning, everybody.
Good morning.
Good morning. Today we're going to be looking at polynomials. Poly means many. Nomial means terms. So a polynomial is just many terms. In standard form, a polynomial is many terms added or subtracted. Let's see if that's somebody trying to get in. And in vertex form, or in factored form, the polynomial is many things multiplied. So the easiest way to see the difference is that standard form, things are added. Factored form, they're multiplied. We're going to start out by looking at factored form, and then we'll look at standard form. So the first thing that we'll look at is the end behavior. The end behavior is all determined by the power term. Let's see what I keep getting dings and things. Sorry. Turn that off. Okay, so the power term tells us what's going on. If we're having a polynomial in factored form, we find the power term by looking at the number in front, and then x, and the exponent on x will be the sum of all these exponents. So P1 plus P2 plus dot, dot, dot plus PM. And we say that that sum is the number n. So we have a sub n, x to the n. So in factored form, to find n, we add up the sum of all of the products, all of the powers of each factored term, and then we multiply that by the number out front. If the number is positive or negative, we write that down. So the number out front, we just care, is it positive or negative? The degree, the n, we only care, is it even or odd? Now we're going to come back to this page. So let's look at an example. Un momento, por favor. Okay. So here we've got a polynomial in factored form. I can tell because everything is multiplied. So this is factored form. Everything is multiplied. Here, the number out front will be a sub n. So a sub n is equal to 2. And we find n by adding up the exponents on every factor. Well, the exponent on the first factor is 3. The exponent, what's the exponent on the x plus 3 factor? There's no exponent written. So what is that? Good. And then plus 2. And let's see, 3 plus 1 is 4, plus 2 more is 6. So n is equal to 6. A sub n is equal to 2. For n, all we care about is n even or odd? Well, here, n is equal to 6. Is it even or odd?
Even.
Good. A sub n is 2. is a sub n positive or negative?
Bigger than 0.
That's right. Very good. So now we look at our chart. This page is a page I've made for everybody. I've printed them all out. So this is something you'll have with you. Let's see. N is even, N is odd. A sub n is positive, negative, positive, negative. So which graph are we looking at?
Positive and even.
That's right. So we've got positive, even. So our graph is going to be up to the left, up to the right. That's the end behavior, up to the left, up to the right. So here's a little picture of it. So our end behavior, up to the left, up to the right. The number of places where this thing turns, can you see in the graph, it's turning. It starts out positive and then it turns and comes back negative and then comes back and changes. The number of possible places where it turns is n minus 1. Well, our n is 6. 6 minus 1 is
5.
good. So we'll get at most 5 turning points. To find the zeros, we're going to take each factor and set it equal to 0 and solve for x. So let's write that down. To find the zeros, we're going to set each factor equal to 0 and solve for x. Well, let's see. Let's take the first factor. We're going to ignore the exponent and just take the x minus 1. So we have x minus 1 equals 0. If we solve that for x, what do we get?
X equals 1.
Good. Now let's take the factor x plus 3. Set that equal to 0 and solve for x. What do we get?
-3.
Good. And finally, we take the factor x minus 5, set that equal to 0. And when we solve for x, we get
5.
good. Zeros are numbers. Let's write that down. Zeros are numbers. Intercepts are points.
So basically that's the x intercept.
That's right. So the zeros for this function are just the numbers. It's just going to be 1, -3, and 5. We care about something else with the zeros. We care about something called multiplicity. The multiplicity is just the exponent. So let's write down those exponents again. What is the exponent on the x minus 1 factor?
3.
And what about the exponent on the x plus 3 factor?
1.
Good. And the exponent on the x minus 5 factor?
2.
Excellent. We say that 1 is a 0 of multiplicity three. For multiplicities, we only care, is it even or odd? Let's write that down somewhere. Multiplicity even or odd. Multiplicity is just what we're going to call this exponent on the factor. So is 3 even or odd?
Odd.
When the multiplicity is odd, the graph will cross at 1. So I'm just going to put cross for now. Okay, what about the factor x plus 3? What is its exponent? Oh, we just said, so -3 is a 0 of multiplicity 1. Is 1 even or odd?
Odd.
If it's odd, the graph will cross. And finally, we have, let's see, we've got -3, we've got 1, and we have 5 is a 0 of multiplicity equal to 2. Is 2 even or odd?
Even.
Good. If it has an even exponent on that factor or even multiplicity, the graph touches. Let's find a blank form. Let me print one out just real fast. Or actually, we don't need to. So we have our overall behavior is up to the left and up to the right. We have zeros, which are like x-intercepts, but we're not including the 0 at -3. Is it +1 and +5?
Yes.
What was the multiplicity of -3?
1.
Since it's odd, we'll cross. What is the multiplicity of 1?
3.
Since it's odd, we'll cross. And what is the multiplicity of 5?
2.
Since it's even, we're going to touch. And there it is. That's the graph. We can get one more value. We can find the y-intercept. So let's do that. I think I just lost my mind today. Okay, so to find the y-intercept, we're going to find f of 0. Well, let's see. That's 2 times 0 minus 1 cubed times 0 plus 3 times 0 minus 5 squared. So we have 2 times -1 cubed times 3 times -5 squared. Let's find all these exponents. So what is -1 times -1 times -1?
-1.
Good. And then we have a 3. And what is -5 squared?
25.
Excellent. And this is good because it's quarters. So if we have 3/4, we've got 75, -75, double that, that's -150.
Mhm.
So the y-intercept is 0, comma, -150. In order to find the value of these places where it turns, you have to have calculus. So we're not going to worry about that. Here's what this graph actually looks like using Desmos. So Desmos.com is a free calculator, free graphing calculator. And if you type in this function, you'll see that it has a really low turning point in between -3 and 1. It flattens out, but does definitely cross at 1, and it touches at 5, but it doesn't go very high in between 1 and 5. That, however, we can't figure out with algebra. It takes calculus. So we don't care. All we care about is where does it cross or touch on the x-axis, the y-axis, and what is the maximum number of turning points? So maximum,
5.
that's right. It's always n minus 1, and that's 5. Well, how many turning points do we actually have? Let's look at the sketch that we've made. How many times does the graph change direction? Is this 1?
Yeah.
And then up, here's another. So that's 2. And here's one more, that's 3. So
Mhm.
it could have as many as 5 places where it changes direction. Ours has 3. Let's do this next example together, even though it says a group. Unless y'all want to try it on your own. Okay.
Can we do it together?
Okay, great. So the first thing we look at is we looked for the power term, which is a sub n x to the n. A sub n is the number out front. So 4 is going to be a sub n. And n, if it's in factored form, n is going to be the sum of all those exponents. So it's going to be 2 plus, because the factor x minus 3 is squared. What about the factor x minus 1? What is its exponent?
1.
Good. And the factor x plus 1, what is its exponent?
3.
Good. And the factor x plus 3.
2.
So our power term is 4x, let's see, 5, 6, 7, 8. 4x to the 8. All we care about with a sub n, is it positive or negative? Well, what about this particular a sub n?
Positive.
Good. All we care about with n is it even or odd?
Even.
Good. So that tells us, we're going to come back to the page that has a chart. And again, this is a page that you could have with you. So here we've got the same first picture. N is even, A sub n is positive. Our graph is going to go, it's called end behavior. It's going to go up to the left and up to the right.
I have a question, if you could go
Yes.
back, please.
Sure.
On the A sub n, you said it's positive, and that's based on the 4. Is that correct?
That's right.
And then the n is the 8.
Yes. And that's just going to be 2 plus 1 plus 3 plus 2.
Thank you.
You're welcome. So I'm going to remember that our graph, if I go far left, it's going to go up. If I go far right, it's also going to go up. It's called end behavior. And I can't write, but end behavior is always based on the power term. And that power term is always a to the n, x to the n. What is the maximum number of turning points?
A minus 1.
That's right.
Seven.
N minus 1, and that's 8 minus 1, and that's
7.
good. Now let's find the zeros. Since we're in factored form, I'm going to take each factor, set it equal to 0, and solve for x. So I have x minus 3 equals 0, x minus 1 equals 0, x plus 1 equals 0, and x plus 3 equals 0. What do I get when I solve x minus 3 equals 0 for x?
3.
X minus 1 equals 0?
One.
Good. X plus 1 equals 0?
-1.
Excellent. And x plus 3 equals 0.
-3.
Marvelous. Now let's write down the exponent on each of these factors. What is the exponent on the x minus 3 factor?
2.
2.
What about the x minus 1 factor? If there's no exponent written, what is the exponent?
1.
That's right. I always circle the exponent. On the x plus 1 factor, what is the exponent?
3.
And on the x plus 3 factor?
2.
What we care about with this exponent, and this is called multiplicity, it's a big word. It doesn't really have anything that's important except that it's the exponent on the factor. And all we care about, is it even or odd? Well, 2 is
Even.
good. 1 is,
Odd.
3 is,
Odd.
and 2 is.
Even.
When the exponent is even, the graph will touch. So at x equals 3, the graph will touch. When that exponent is odd, the graph will cross. So at x equals 1, the graph will cross. So again, for the 0, -1, it's odd, so the graph will cross. And at x plus 3 equals 0, we have 2. That means the graph will touch. So let's make a sketch. We've got zeros at -3, -1, 1, and 3. And what am I doing at 3? Let's see, at -3.
It's gonna be a touch.
Touch, good. We're coming. We are up to the left and to the right, so we're coming from above. We're going to touch. That means that we're going to have a turning point right there at -3. At -1, oh yes, good.
Sorry. So that -3, we're just going back to the zeros of the x minus 3, correct?
That's right. For the x plus 3, we get the x minus 3, x equals -3. So we solved the x plus 3 equals 0 factor for x. We got x equals -3. It had an exponent of 2. So at -3, the graph will touch. So we have to remember what factor it came from. Yeah, that's a very good question. What about at x plus 1, the 0, x minus 1? Do we touch or cross?
Cross.
And how do we know?
So odd.
Yeah, the
Exponent.
exponent on the x plus 1 factor is odd. It's 3. So what happens at x equals 1? Do we touch or cross?
Cross.
And do you see, in order to get from -1 up to 1, I have to turn. And finally, at x equals +3, here we go. That's the x minus 3 factor. Do we touch or cross?
Touch.
In order to get from 1 back down to 3, I have to turn. So let's count the number of actual turning points for this graph. Starting from the left. Yeah, Alicia.
So whenever we are doing the graph and we're doing the touching or the crossing, do we start at the very top, the x minus 3 equals 0, x is 3, or do we start at the bottom?
We start at the left. So we're not going in this order, we're going from left to right on the x-axis.
Okay, but we're
So
starting at the bottom, graphing
Well,
the
yeah.
-3 up, right?
Yes, no matter what order these are in, we're going to start at the leftmost 0.
Okay, thank you.
You're welcome. And the end behavior tells me if I'm coming from above or below. Okay, good. Again, calculus tells us where these turning points happen and how high or low they are. So we're not going to worry about that. But we can count how many turning points there are. So we're starting from above, we get down to -3, and what happens? Do we turn?
No. We cross -1. Yeah, turn and then cross.
We turn, so 1 turn, 2 turns, 3 turns, 4 turns, 5 turns. So this graph has actual turns is 5. So even though there could be 7, there are actually only 5 turns. A turn is where it changes direction. Let's see if we can find this value on the y-axis. Well, to find the y-intercept, we're just going to find g of 0. Let's see. That's 4 times 0 minus 3 squared times 0 minus 1 times 0 plus 1 cubed times 0 plus 3 squared. So we've got, what is negative 3 squared?
9.
Good. And then this middle number is just going to be negative 1. What is positive 1 cubed?
1.
Good. And positive 3 squared. What is positive 3 squared?
9.
Good. So let's see. We've got 9 times 9. That's 81. Times a negative. That's negative 81. And then we need to multiply by 4. So we need to find 81 times 4. That's 324. Is that right? 8 times 4 is 32. 4 times 1 is 4. Yeah, and it's negative. So the y-intercept is 0, comma, negative 324. We don't care what the graph looks like. What we care about is that this point is going to be 0, negative 324. So I'm going to make one up for y'all to do. So I want you to analyze and graph f of x equals 2 times x minus 1 cubed, x plus 2 squared, x minus 2 cubed, x plus 1 squared. So I need the power term. And that means we need to know what a sub n equals and what n equals. We need the zeros, the multiplicity of each zero, and the y-intercept. The power term, a sub n x to the n, gives us the end behavior. And we're going to use this chart for the end behavior. Okay, I'm going to pause the recording and go away, but I want y'all to figure this out. And I'm going to be right here, so I'm going to listen. Now I did. Shoot. So y'all have the benefit of that extra. I'll record some more later. So the graph of a polynomial is smooth, which means no corners, and continuous, which means no gaps. So for instance, smooth, no corners, no gaps. What about this graph? Is this possibly a polynomial?
No.
And why not? That's correct. Why not?
Because you hit the corner.
Yeah, we have a corner. We cannot have a corner. And what about this graph? Can that be a polynomial?
No.
And why not?
It's not continuous.
That's right. It has a gap, not continuous. So a polynomial curve is always smooth, no corners, continuous, no gaps. In order to see what's happening with a polynomial in standard form, we have to factor it. We have to figure out what the factors are. And there are two primary things we're going to look at: the difference of two squares and factoring by grouping. The difference of two squares is always, you have the perfect square minus a perfect square. You find the square root of the first number, the square root of the second number. The first numbers go in the first position, the second numbers go in the second position, plus in one and a minus in the other. So let's look at an example and see that it's not that big a deal. Can I write x squared minus 4 so that both numbers look like they're squared? Can I write 4 so that it looks like something squared?
Yes, 2.
Good. So that means I'm going to have the square root of the first thing. What is square root of x squared?
X.
And what is the square root of 2 squared?
2.
And then a plus and a minus. Plus in one, minus in the other. So how would we factor 9 minus x squared? Can we make it look like the same pattern?
Be x minus 3, x plus 3,
So what comes first though?
x plus 3.
So the 3 comes first though. So we've got 3 squared minus x squared. It'll be 3 minus x, 3 plus x. So the 3 has to come first. Okay, factoring by grouping is one of the most powerful factoring techniques. So you have to have 4 terms, and we're going to group the first 2 terms and the last 2 terms. So first 2 terms, and the last 2 terms. In the first 2 terms, we're going to see what is the greatest common factor. So what is the largest thing common between 12 and 4?
It's like the minimum common denominator.
It's like the greatest common factor. So the smaller. So what's the biggest thing that's the same between 12 and 4?
4.
Good. And between x cubed and x squared?
X squared.
Good. 12 divided by 4?
3.
Is it me?
No, sorry.
Oh, that's okay. And then we've got x cubed divided by x squared. That leaves
1.
if I have 3 x's and I pull out 2, yes, it leaves 1 x. We have a minus sign. Now I've got 4x squared divided by 4x squared. If we have 4 divided by 4, what do we get?
1.
Good. So the first 2 terms, we have a 4x squared common, and we're left with 3x minus 1. With the last 2 terms, there's a negative in the front. I have to factor that out. Is anything else common between 3x and 1?
The 1.
Yeah, just 1. So I have to pull out a negative. Anytime there's a negative in the middle between the 2 terms, we have to factor it out. What is negative 3x divided by negative 1?
Negative 3x.
If we divide by negative, yes, good.
Yes.
And what is positive 1 divided by negative 1?
Negative 1.
Good. That's this step 2. So we've grouped the first two and the last two terms together. We factored out the greatest common factor from the first two terms and the last two terms. Now we want to see, is the remaining binomial, bi means 2, is the remaining binomial the same? Do these two terms match?
Yes.
That means that factoring by grouping will work, and we're going to factor that factor out front. Now let's write down what's left. In the first whole thing, we've got this 4x squared left. What's left in the second part?
-1.
Good. And that was step 4, combining the remaining terms into one factor. But now I notice that 4x squared, that's a perfect square. Is 1 also a perfect square?
Yes.
That's right. I can write 4x squared as 2x squared, and I can write 1 as 1 squared. The square root of 4x squared is
2x.
and the square root of 1.
1.
And then I put a plus in one and a minus in the other. So I'm going to come back over here and write it in. So we were able to continue factoring the 4x squared minus 1 into 2x plus 1, 2x minus 1, using the difference of two squares. Well, let's go through this next example together, even though it says by groups. We want to factor by grouping. And let's see, let's look at the steps. We want to group the first two terms and the last two terms together. Now we want to pull out anything common in between the first two terms. So let's do numbers and x's separately. What's common between 3 and 6?
3.
Good. What's common between x cubed and x squared?
X.
X, what's the biggest power of x we can have in common?
2.
Good. 3x cubed divided by 3x squared. The 3 divided by 3 is 1. What about if I have 3 x's and I take out 2, what's left?
1.
Good. Then I have a minus sign. 6 divided by 3,
2.
and I have 2 x's and I pulled 2 x's out. How many x's are left?
0.
Good. There's a plus sign in the middle, so I put a plus. Is anything common between x and -2?
1.
That's right. With grouping, it always helps to write 1 down. If that's the only thing common, go ahead and write it down. So that means I have 1 times x minus 2. Now I want to see, is the remaining binomial, two terms, does it match? Does it match?
Yes.
That means factoring by grouping will work. And I'm going to take this x minus 2 out front. What's left
3x.
out of the whole? Yes. And out of the second clump?
Plus 1.
Good. This time, can we keep going factoring? Do we have a minus in between?
No.
That's right. So this is it. This is, we're done factoring. We have factored quadratics, ax squared plus bx plus c, where the a is 1, by finding two numbers whose product is c and whose sum is b.
I have a question. I apologize.
No, it's
Are
good.
these different notes? Because the ones that I printed out yesterday, I don't have this.
Yeah, I added last night.
Oh, okay. Okay, sorry. Okay, thanks.
Yeah, sorry. And actually, this is a great, thank you. So I want to show y'all. I'm going to change the share. So I want to show y'all, if I go to our homepage in Canvas, and I go to modules and class recordings and notes. All of our notes are there. And this particular set of every single day, I post the solutions for the notes. Here we go. The reason why I wanted to show y'all this particular solution is that I color coded all of that graphing. See if it'll open. I agree with that yawn. Here we go.
And before we disconnect, can you let us know what homeworkers do?
Yes, absolutely.
Yeah.
So all of the graphs are in here the way Desmos would see them. So you can see the bigger turning points. Oh, this isn't, oh, well. So let me, I thought I uploaded the new notes, but I'm not seeing them here. So I'm going to stop sharing and reshare. Word. There we are. Okay. Here we go. Can y'all see my document?
Yeah.
So here's the factoring on page 4. I tried to put a lot of color coding in how you go about finding A and B for the difference of two squares, and especially this factoring by grouping, looking at the first two terms, the last two terms, making sure it matches. I just tried to do very interactive, not interactive, but descriptive notes here. So, and then the problem that we just looked at together, that doesn't match the one that we just did. Oh, okay, never mind, because the one that I actually did here is not the one that matches that, so who knows? So we're not going to be able to finish these notes, but we'll pick up looking at how to factor a quadratic in the form ax squared plus bx plus c when a isn't 1. And we'll look at those examples on Monday. Oh, Monday, I'm being observed by the chair of the math department. So let's all, I'll make sure to send out an email, but it's a good day to come on time and be really, really active participants. Any questions before we ring off?
On the homework, it shows that we have.
Oh, the
two
homework, yes. Yes,
Friday.
let's go ahead and look at homework. And I have to stop sharing and reshare, don't I? Let's see, Safari. Okay, so let's look at Connect Math. Thank you for reminding me, Alicia. So we've got, and I've opened every single assignment. So all of the assignments in our whole semester so far, including the one that's due on Friday, are available to improve your grade if you want to. And then let's see, the 26th is Tuesday next week. Yeah. So our next assignment after the quadratic functions isn't due until next Tuesday.
So I still have 2.8 that's due on Friday, correct?
All
Even though we-
of the previous ones were due earlier, but I opened them all up.
Okay, all right, thanks.
Yeah, so every single old assignment is available. The only new thing is this 3.1, and I made that also due on Friday. So this is a good time to go through Connect Math and improve or fill in old information. All right, any other questions? So we'll finish off the polynomial section, the section 3.2 on Monday. Thank you, Cecilia.
Okay,
Have a great weekend.
Thank
Happy
you.
weekend.
weekend.
Bye.
Thank you.
Thank you. Bye-bye.
Bye. Oh, I have a little question.
Sure.
But
After
I'll
2
wait.
minutes.
I wasn't able to finish the Connect Math for, I think it was like 2 point something, because I thought it was due on the next day. When I tried to do it, it was already closed. Is there any way I could do it?
They're all open. I opened every single old assignment,
But even from exam 2, from the
all of
one.
them. Yeah, all of
Oh.
exam 1, exam 2, everything is open.
Oh, okay, good. I'll go right now. Thank you.
You're welcome.
Bye. Have a nice weekend.
You too. Thank you, Fatima.